Hello everyone. Today we'll talk about AI agents. So this is a typical journey evolution of AI capabilities. We ourselves have done that over this series. Traditional programming, where we write the logic ourselves. We write code explicitly. This is what is called as rule-based programming. Then we looked into machine learning, where typically in supervised way, we give data, which is input as well as output, and let the computer figure out, let the algorithm figure out the transformation, the model, the function. Similar things, but done, if done, using neural networks, we call it deep learning. Again, there the feature engineering happens automatically, internally. In machine learning, we have to, or we have chance to give or do feature engineering. Then came foundational models. Why they are foundational? Because they can do multiple tasks. Previously, if we had to do sentiment analysis, we had one model. If we had to do house price prediction, another model. But foundational models are the models which can cover multiple use cases in a single model. Large language models that we all know are typically foundational models. Many of them are foundational. Then came AI agents. By the way, AI agents in theory or even in practice to an extent were there decades ago, but they are now, now more popular. Stuart Russell and Peter Norvig's book on artificial intelligence actually talks about the theoretical aspects of agents, AI agents. So AI agents is what we are going to talk today. As we know, in November 2022, ChatGPT came and it became a watershed moment in AI. And it was what is called as conversational AI. It was question answer system. You put question or query, what is typically known as prompt, and then you get answer, what is known as response. So this was sort of a question answer system. But later, of course, it was very, very effective, transformational. But then people wanted not just response, but action on the response. Okay, that was the idea. So that's where agents come in the picture. So instead of just giving answer, can we do some action? Action, by the way, simplistically means calling an API, calling a function, or doing some action in that sense. Not like physical action, but some action which has been predetermined. So now we are shifting with agents from just getting the information to doing something. And whenever we are doing something, that's what is called as agents. Let's take an example. If a family of four wants to do a trip from Pune to Manali, spend a week there and come back. So in a ChatGPT way, you would ask this to ChatGPT or any other LLM like Gemini or whatever, that I wish to plan a week-long trip to Manali from Pune. These are the four members. These are the preferences and all. Plan me or give me a plan, itinerary, right? That's the idea. And it will give wonderful day breakup, what you would do on day one, day two, day three, so on and so forth. It will suggest you names, where to stay, where to eat, all that thing, airlines and other things. So this is just giving the response from this is what here we are calling it state A, point A, just discussing the trip. But we wish to have now action. Action meaning not just the answers, but do all the bookings themselves. The airline bookings, the hotel bookings, the restaurant bookings, everything autonomously on its own. Right? That's where we wish to land. Because why we are doing this? If at all we get this ability, then we will save time. And of course, by saving time, you don't have to go here and around. You don't have to hire a agent, trip planning agent, physical. You save money. So idea of agent or the value of agent is in saving time and money, right? That's the main idea. Agent adds value by saving time and money. By the way, if agent is not doing this saving of time and money, why employ agent, right? Yeah. By the way, agent now onwards is AI agent, not the physical agent that we typically know of. Okay. So what agent has to be given a prompt, like I wish to plan a trip from Pune to Manali for a week or so. It has to plan things. It has to do what is called as task breakdown. So travel part, staying part, eating part, all that thing, it has to plan and make decisions because there are multiple choices available at each stage, right? Then it will decide the choices based on the budget typically, and of course number of people and other things, their ages and other things. So there are constraints also. Another thing could be for planning day one, day two, day three. For planning day three, it should not again put what it covered in day one, right? So all that planning and decision making it has to do. So second aspect of agents, first one is saving time and money. Second aspect of agents, being an agent, is agent can plan and take decisions. Now there is some action that is coming slowly, right? It is deciding something, not just giving you 10 options, not like 10 blue links. It is deciding the plan. It is doing task breakdown. Now to do actual action, it has to do bookings, meaning it has to have some actionable items, some tools. So, right, some tools to do the action. And here, in this case, in the case of software, it is nothing but calling a function, which will do booking, calling an API, which will do the airline bookings. So basically calling external tools. It can be even search, Google search, just to get all the restaurant options or hotel options and other things, right? Search, booking APIs. So agents is where you have access to tools to do the action. So saving time, the value in saving time and money, we should be able to do planning and take decision, and we should have access to tools to carry out the actions, right? So this is another aspect. By the way, this diagram will go on adding to itself, augment itself, so that the whole definition of agents is clear. To do all these things, we need a powerful system behind, and that's why agents became popular because of the advent of LLMs, large language models. Because especially reasoning models are the ones which do step by step thinking and then step by step action oriented task breakdown. Reasoning and thinking models. Because of thinking models, these things are possible. Doing task breakdown, calling functions and other things, calling tools. So we have LLMs as brains now and tools as hands or legs to do action. LLM will think, tools will execute. That's the idea. So this is another aspect of agents. So this is what is the final definition, we slowly built it up. Agents can learn from feedback. So once we did the planning, did the whole thing, and then we are now ready. Agents can learn from feedback. If there is mistake, we can give feedback and it will redo the whole thing. Wherever it is changing, it can do the whole thing. And that's how it will optimize and give you better and better solutions. So learning is self-improvement based on the feedback. That's the idea. Hope that's very basic though, but that's the whole journey of understanding what is an agent, what do we expect from an agent, AI agent. So this is just a summary slide. You can just have a look. So there's a technical view of being an agent. So we have to have LLM as brain, tools to do actions, planning, strategy, memory, and state management. This is the technical stack. This is the way we understand agents in the implementation sense. In business sense, of course, being autonomous, taking feedback, learning from outcomes, being measurable, all these aspects are business aspects to it. So both aspects is right, but being developers, being technical people, in this session will focus more on the technical view of agents. There are few concepts which are very, very important in understanding agents, and this is one of them. Okay. This is what is called as REACT, react, reasoning and action loop. So there are three conditions for being an LLM. As we saw, actually, we saw quite a few things, but technically, you have to have an LLM, you have to have access to tools, and the third important thing, you have to have a loop. Why loop? We'll explain. Till the time till the moment the whole action is complete, it will go on repeating and refining itself. And that cycle is called as Tao cycle, TAO, thought, action, observation. So what that means is, unlike LLMs, unlike ChatGPT, Gemini, which give question and answer, which are sort of sequential, this will do a while loop like thing till the task is done. So first of all, whenever query comes, thought happens. How do I solve this problem? How do I plan next steps? Then tools are called to execute things. The next is the important one. After the tools are executed, after the action is done, there is an observation saying that whether my original intent has been achieved or not, it is done or not. If yes, exit. If no, go back. Do till everything is done. So this is an important aspect typically not covered. So typically we know agents are just a composition of LLM and tools, not the case. Typically agents are implementing the React pattern. React pattern is the same pattern that I've talked. I'll show you one more slide. Reasoning meaning task breakdown, planning, understanding, and acting, react. This is the paradigm. And it of course has memory. What all happened so far, that memory, the context has to be stored somewhere as history, conversations, sessions, all those things. And then in some cases, before taking any important decision, important actionable decision, we may have to ask humans. For an example, if you want to purchase something, if you are doing airline booking, bookings are done, selected. Now we have to do payment. Payment typically, we are not, as humans, are not comfortable to give it autonomously, right, or on its own. So there, we may decide to put human in loop and take OK and approval or disapproval from human and then go ahead. So why I'm giving this idea? Most or rather all agentic systems or agentic frameworks like LangChain, LangGraph, or many others that we will see today, or few of them that which we'll see today, will implement these methods, these aspects. They'll have LLMs, they'll have access to tools, they have loop, react like pattern, they'll have memory, and they will have facility to have human in the loop. That's the idea. I'll let you understand same thing, which you can easily see. Query comes, thought is given, planning, decision making, and other things. Action is done via tools. Observation is made. If the observation says the original intent is not covered, looping happens. Still, once the task is over, finish the answer. This is the rough idea. By the way, this is the paper. I'll mention that again, which sort of talked about this React pattern. It's very simplistic pattern, but this is very important pattern. So this is what happens. Okay? Typically, this is the thought trace. Once you put a query, what all happens in the background? Actually, if you watch very closely, and this happens with reasoning models also, reasoning LLMs also, when you put a query, what is the weather of New York? Then you can see that it is thinking, and it like it's like open thinking that it does. Huh? Oh, user wants the weather in New York. I have a weather tool, yes. So it is just talking to itself. My next move, call get weather, because I have a function called get weather, and in its description, it is mentioned that given a city, it will give the weather. It's basically an API call. So this then gives that handovers the action to this get weather API tool. And then this is what happens. So this is how agents work in the background. Okay. Another important concept now, initially I sort of hinted that they'll do this work autonomously. Autonomously means on its own. But autonomously means not fully autonomously. There are grades, there are shades, there are levels of autonomy. Being on your own, it's not like full 0 or 1. I have no autonomy, I have full autonomy. No, there are various levels, and certain agents or certain problems are solved up to certain levels. I'll take one example and then, of course, elaborate. We're doing manual car driving, right? Many of you may have done, or vehicle driving. If everything is in our hands, no decision is made, then it is probably level 1, right? And fully autonomous car. We have seen that Waymo and other things which are there in LA. You just have to sit and punch in destination and it goes. So that is sort of fully autonomous. It will not fully autonomous there. Probably it will also decide the destination based on what we thought. That's too much, but probably level 4. So these are the grades of autonomy. What is in between autonomy? There is something called as cruise mode. Those probably who have driven in US, when the road is straight, probably for an hour or so, you just put the cruise control on, and then it drives itself. So this is sort of semi-automatic, isn't it? So there are levels of autonomy. These are important to know because then we have to just see where our current agentic system is at. I will not read all this. I'll let you read. Hopefully it is visible. So low agencies where less autonomy is there, more human handholding. Just to give you a sense, as autonomy increases, as automaticness increases, there's more value, of course, but it becomes more complex. It becomes more independent on its own. And then if it makes mistake, what to do? So it is, of course, as the autonomy increases, complexity increases, and the debuggability is hampered, becomes lesser and lesser. How to correct things if it is more autonomous? So I'll let you read the levels of autonomy. And many agentic systems you will find can cater to multiple levels of autonomies, agencies. So degrees of autonomy. So then there is a debate. What do we call agents? Now somebody came up with this term agentic. Agentic is actually meaning this autonomy is in the full spectrum, meaning all levels. Some aspects of being agent, if they are found in certain systems, then we can call it agentic. Okay. It need not be fully autonomous. Basically, that's the idea. It need not be fully autonomous, then only we'll call it as agent. No, we'll call it agentic, right from far less agentic to most agentic. That's why we are seeing this use of term agentic, RAG, agentic, whatever, multi-agent systems and other. Perfect. Some examples, less autonomous agents, lower degree of autonomy. More LLM decide almost everything, and then of course the tools get called autonomously, even the approvals happen, all so on and so forth. Tools. As LLMs are brains, tools are the hands, those which do the things. And we'll see some examples later. Basically, these are nothing but search API calls or even other API calls or function callings, basically. Some little finer aspects of tools, some agents, when like an API, if you post an API, you get the JSON as a response back. In some cases, nowadays, for an API call or whatever, for function call, you need not get just the JSON response JSON, which we have to pass and then process further. Some systems now give code also, Python code. I just wanted to mention this is little slight deviation from what typically we see in a API call. And then once the code comes, we execute the code. Typically, you may see such things in Claude. Claude, I've seen this personally. All right. Now, another important thing, we see some of the aspects of making agentic system. Okay. LLMs, as you know, um, they work on tokens. Tokens are not exactly words, but sub words. So typically, I've given some ratio here. So uh, in even question answering systems of LLM systems, we have to consider um, context window. Context window is nothing but input that you provide, all the processing that happens, as well as output. The whole thing has to fit in like 4K, 10K, whatever the context window is. Nowadays, it is less of an issue because now the context window of most of these top guys has become 1 million tokens. But still, for not such big systems, for SLM, small language models, the tokens context window is limited. This is more apparent in agents because as we saw, LLMs, rather agents have to do multiple loops till it arrives at the answer. So multiple LLM calls and the earlier ones should not be forgotten. They have to be kept in memory, maybe summarized, put back in the prompt. So there, the sense of being within the context window is more important. That's why I put this point here. We slowly come towards the agentic frameworks now. Okay. We saw what is agent, what are AI agents, some aspects of it. Now we'll see some things related to agents, and then we'll see an example also or actual implementation framework where agents are defined and executed. Okay. So, as we said, another important aspect apart from LLM tools, context window, this is another important aspect, memory. As we saw, we cannot just go on using keeping everything in the prompt because the context window is limited. We have to offload. We have to offload each sessions, each loops information somewhere in memory. And there are multiple types of memory in that aspect. Most of the agentic frameworks do provide these four types of memories. Memories also have type, like current conversation I have to keep, right? Because if I refer to something else as show me that city's weather, what is that? Right? I must have said about, say, Mumbai in the previous question answer. So that one has to remember. So this is in context memory. It has to be stored. So this is in session, in the conversation, what has happened. Another memory is, and you might have seen this is in ChatGPT, they have all the chats stored. Even Claude stores all the chats. But we can build agentic system with past sessions themselves, all the past question answers, the history, past all histories can be stored as episodic memory. Now it can be stored in some database or whatever. That modality one can check. But not just the current conversation, not just the current history, but past histories, past sessions can be stored because they can be useful. Because if I had done certain similar things in the past, I need not even think. I'll just push those things as answers. Another important thing is word uh, world knowledge, basically external tools. This is semantic memory. This is nothing but if you can remember RAG, retrieval augmented generation, whatever I'm talking about, I can bring some external knowledge in the prompt from VectorDB or other means. And another thing is procedural. System prompt is another important knowledge understanding or skills that typically these Claude systems have or instructions in, I think, GitHub Copilot base. So these are memories. All these things are used to answer um, your question or get things done. As I said, most of these guys, by the way, these are the names of agentic frameworks. They do provide these types of memories. A few patterns, agentic patterns, and then we'll see the implementation. Very basic implementation. We all know about RAG. Uh, Last time we had that session. Retrieval augmented generation. For a query, we fetch in the relevant knowledge in the prompt itself, and then we answer. That's about it. One go, right? For a query, bring in the contextual knowledge, answer within the given contextual knowledge. That's it. But when we call it agentic RAG, meaning it can go in a loop now, right? It can have access to tool calls and many other things. So multiple aspects, but just to give you a high level idea, being agentic is nothing but it will not stop till the query is fully answered. And multiple aspects of it are also shown here. Of course, that is more complex, more LLM calls, and hard to debug in that sense. Again, multi-agent system, not just one agent at a time. We can have multiple agents, digital teams. We can have one manager or a lead team. We can have a QA agent, a UX agent, developer agent one, senior developer, all these things. Their roles are defined in the prompt. Their LLMs could be different. The tools that they may have could be different, right? All these things, we can form a digital team itself using agents. And this aspect is getting very, very popular these days. That's why I'm sort of touching upon it. Uh, Down the road, I believe, just like we have Naukri.com for humans, we may have agentic for agents where we can hire because these agents are defined that way. They have their own access to tools, prompts are defined properly. We just hire them and get things done. By the way, this has started happening. Um, Another few other concepts. Agentic workflows typically have reflection, self-criticism. That's the observability. Have I done correctly? If not, I have to go back. tool usage, planning, and then multi-agent collaboration. All these things are found in agentic design patterns. Reflection and tools usage, planning, and multi-agent collaboration. All right. Now, an important aspect, everything is not like hunky and dory, everything is looking good, but there are, of course, challenges. In single LLM call itself, we get what is called as hallucination, meaning we get wrong answer very confidently. Confidently because it is the chosen one, which has highest confidence probability, isn't it? Now we have multiple LLM calls. There the predictability goes down itself. Each LLM call can potentially hallucinate, isn't it? So LLMs being probabilistic, meaning non-deterministic. The whole sequence of LLM calls can be far more non-deterministic, isn't it? So predictability is an issue. And we'll see how to mitigate that, meaning how to lessen that aspect. Stability, error handling, security, privacy, all these things that we saw in some portion in LLMs becomes aggravated, becomes amplified in agents because there are multiple calls. And of course, operations. Now we have to manage not just a single chat window, but multiple agents doing their own things, right? So it is far more complex. So these are the aspects of, these are various challenges that agentic systems will have to deal with. I won't read through, but you can just go through the predictability challenge. As we know, single LM, same question, if you ask once again, it gives a different answer. Because of course, there's a probability that plays behind. And typically agents, apart from just giving answer, if they have to give, do function calling, tools calling to do action, then they have to be correct, isn't it? Instead of doing booking for Manali, if they do booking for Simla, that's not going to help, right? So predictability is a big challenge in agentic systems. And then these are some of the aspects. So evaluation of agent, I'll cover some of the things little later. Evaluation is the most critical part in agentic systems. Stability, tool calling, error handling. By the way, with the advent of MCPs, MCP is nothing but a standard protocol for calling functions or calling APIs, right? So that standardness has brought some stability, but the tool itself can behave oddly, right? Who can stop that? Operations challenges, logging, relearning, and then distribution of agents, their own cloud environment, many things. Of course, MCP I just mentioned. All right. One last important theoretical aspect, evaluation, and then we'll see some code samples. Um, LLM evaluation, just plain LLM, question answer LLM itself is very challenging. Assume that you have built an Q&A chatbot, simple FAQ chatbot. For given question, it will give answer. And we have standard FAQ as RAG-like solution or it's simple LLM. So for a query, it gives you a couple of lines. But same query in another LLM or in same LLM little later may give meaning-wise same answer, but with different words. That's always possible. Meaning-wise, I stay in Pune, I live in Pune. Right? Words are not exactly same, but the meaning is same. So LLM evaluation itself is complicated, challenging, and typically we use vectorization, which understands semanticness, or LLM as judge, and many other things. Now, evals of agents is far more complex because it has to not just give answer, do a function call or API call, get the answer, formulate the whole thing multiple times, and give you final summary, right? Final answer. So agentic evaluation is at multiple complex levels that happens. So agentic evaluation is important. I would read to just go through once again. Um, and then not just one agent, but multiple agents doing multiple things. That's why, although these systems like GitHub Copilot or even Cloud Code or Open Code, we can define multiple agents, give a problem like build an app for stock prediction, and UX agent goes, developer agent goes, this, they do all these things, bring back their code, integrate, deploy, all this thing. This appears magical, and it is magical, but whether they have done exactly what we want, that evaluation is still dicey at places. For simple, smaller tasks, it is obviously working very nice. But for mission critical applications, for enterprise level applications, EVAS is the biggest headache. Evaluations are hard upfront because what these APIs will bring in, how the orchestration meaning sequencing will happen. Will it happen my way or their own thinking way, LLM's thinking way? We don't know. So typically the mantra is best practices. At least build first. Let's see. Let us see evaluation one by one. So this is the idea because we cannot foresee what may happen. Of course, we can have problem specific golden truth. Like for this value, this has to come. For this value, this has to come. But that may not be the case always, not that crisp. Subjective evaluation, domain specific evaluation, where LLM as a judge is very suitable. LLM based scoring. Okay. This is the summary slide. All right. I've covered most of the theory now. What are agents? What are the levels of autonomy? What are different aspects, tools, LLMs tools, then memory, all these aspects. And then now we'll see a small example of how agents look in code. Before that, these are some of the important publications, papers that one should refer to if you want to understand AI agents better. The React paper I mentioned last time, this is chain of thought paper is also important. Chain of thought paper, tool former. Tool former is where this function calling or tool calling sort of got popular, and then generative agents, multi-agent systems. These are some of the important papers. If at all you are inclined towards research, if you like to read research papers, these are the 4 papers I would suggest. Most important, of course, is React paper. All right. Now we'll quickly go over the lay of the land, meaning what frameworks are available to us. And I'll give one example, one framework, and then show a couple of examples there. Many Python-based, as I myself work only in Python programming environments. So Python has quite a few agentic frameworks, agent frameworks. LangChain and LangGraph is what I personally use. They have been there for a few years now, very mature. They can have a single agent. Typically, LangChain provides a single agent, and LangGraph is an agentic workflow. The predetermined workflow is what their um, prowess, their power is. Uh, Meaning deterministic agentic workflow is what they can automate. LangChain and LangGraph is one system. Pydantic AI, again, very lightweight. Pydantic, if you know, this is actually a type checking library. In LLMs, whenever LLMs give answer, say in a JSON form, are these types matching? Exactly, or else we can get the error raised there and there itself. So they have got agentic system. QI is a very nice framework. I started with QI initially. It used to be very easy to define and work with, but now I believe it has become a little complex to use. But it is mainly for multiple agents working together in a group setting. Interactive agents is their forte, is their prowess, is their power. You can assign rules, you can assign LLMs tools, and all define all the agents. We'll see one example similar to that, and let it do brainstorming. That kind of use case, Crew AI handles. AutoGen is by Microsoft, and it is open source, free. And then you can do similar things. Again, it's a multi-agent conversational framework. Initially also, I used to love, I had a couple of blogs on AutoGen, but later it became a little complex for me. OpenAI has agents SDK. Google has ADK, Agent Development Kit. So just one summary slide, I'll let you read. I did not mention Agno because I'll be covering Agno now. All right. Agno is very, very lightweight. It's almost like an academic system, easy to understand and easy to start with. That's why I've taken this as a framework. I'll show you two examples and that's about it. You'll get the idea. Again, this is free, open to all. One can start with this. So there you can define agents, tools, memory, knowledge stores, RAG like thing, and an orchestration. Orchestration means handling. Like a musical orchestra. In musical orchestra, there is an orchestrator, a conductor who conducts all instruments, tells them what to do, what not to do. Similar orchestration is possible in multi-agent systems. Level of autonomy it provides. I'll just let you go through it once. Important aspects is it is not tied to any LLM company, not tied to OpenAI, Claude, or whatever, or Google Gemini, um, and then Microsoft. It's model agnostic. It is indifferent. So you can have many models. Good performance. It's still a very small framework. So it is good for class assignments and other things for sure. I'll just show you two examples. We'll get simple way to install, pip install. It has multiple things. Okay, I'll wait here. I explain this thing in detail. One example and another two agent example I'll show. This is single agent example. This is agent class. You have to provide model name. Here you can put anything that is available as a library here. I can use OpenAI and other things. So this is the brain that you are defining an agent. Okay, you are giving it as a brain, giving it a brain, LLM here, and tools. The hands it has access to. It has access to reasoning tools, some function available here. And my finance is nothing but Yahoo Finance API call to fetch in stock values for given labels, Google or whatever. It will fetch in the stock prices. This is the prompt instruction. This is the role definition. This is the prompt, and this is the actual query. So once the agent is defined, you can just call it to get things done. This is nothing but putting a prompt. That's it. And the answer to this agent is run. So this is what, like 20 lines of code, and we have agent working. It has all the aspects. Of course, memory aspect is not explicit here, but it has LLM, it has tools, and you can call it with a query. That's about it. There's another thing, the MCP and other things. I'll not same thing, agent definition only, but you can run that agent in a cloud way, agent OS and other things. But same example, if you see. All right. I'll show you multi-agent scenario now. This is this multi-agent. I'm showing only two agents as of now. Similar to last time, we have defined one agent called web agent, role, its model, its tools. DuckDuckGo is nothing but a web API, a search API. Instructions and so on and so forth. Similarly, I'm defining another agent, finance agent. So I have a web agent and a finance agent. Using these two agents, can I form a group and give a task to the group? That's the idea. There you go. Now I have a team. I'm defining a team, a group. I'm giving two agents as my members. It can be a QA guy, developer guy, UX guy, if you have defined those agents initially. Success criteria and instructions, and then given a task. So this is how multi-agent system. I'm showing very academic and simplistic examples, but you get the idea. This is how agents look in the code. So that's what I wanted to cover, a very high level, very basic idea of what agents are. I'll quickly go over these things. I think it's covered mostly. Okay. Just to show, I have a sketch note. You can search for it, power of autonomous AI agents. In a single page, you get all the idea of what mostly I covered in this session. You can search for it and get it. So that's about it. That's what I wanted to cover.